Is humanity alone in the universe, or are we simply too primitive for an advanced civilization to bother contacting us? Regardless of the answer, it can be disheartening to contemplate the vastness of the cosmos and the absence of any signs of intelligent life. How is it possible that in a universe of seemingly infinite probability, Earth is the only place where the ingredients for life have come together? And if similar conditions have arisen elsewhere, where are all the aliens? On December 25, 2021, NASA embarked on a new chapter in space exploration with the launch of the James Webb Space Telescope, JWST. As the successor to the iconic Hubble Space Telescope, the JWST represents a significant leap forward, promising to be 100 times more powerful. This telescope, the result of over 3 decades of meticulous development, is designed to capture vast amounts of light and intricate cosmic details exceeding the capabilities of Hubble. 6 months after its launch, the JWST revealed its first major accomplishment, Webb's first deep field image. This groundbreaking image features not only stars, but also an array of galaxies spread across immense distances. These distances are so vast that even light, traveling at its incredible speed, would take millions or billions of years to reach them. By studying these images, we are effectively looking back in time, gaining invaluable insights into the early history and evolution of our universe. Given the vastness of the universe, it's astounding to realize that everything captured in this single image would be comparable to the width of a grain of sand held at arm's length against the night sky. Within the observable universe, there are hundreds of billions of galaxies, with some estimates suggesting that this number could reach into the trillions. Each galaxy houses hundreds of billions of star systems, much like our own, and within these star systems, numerous planets orbit their stars. Considering the staggering number of planets scattered throughout the cosmos, it prompts a profound question. What are the chances that there isn't another planet harboring life in some far-off galaxy? When we ponder the sheer immensity of space, the question arises, are we truly alone in this unfathomable expanse? It's fascinating to consider that, given the sheer scale of the universe, there could be millions, if not billions, of planets with the potential to support life. Life could thrive under a variety of conditions, such as different temperatures, varying distances from stars, the presence of water, and the number of moons. Since the fundamental laws of physics, chemistry, and biology apply universally, the possibility of diverse life forms existing elsewhere is quite plausible. With so many chances for life to develop, we are left with a perplexing question. Where are all the aliens? If life isn't unique to Earth, and the universe is brimming with potential habitats, the lack of contact with extraterrestrial civilizations becomes an intriguing and profound mystery. In 1950, Nobel Prize-winning physicist Enrico Fermi posed a compelling question during a casual conversation with his colleagues. Given the vastness of the universe and the potential for civilizations capable of space travel, why haven't we encountered any extraterrestrial beings? Fermi noted that considering humanity's relatively brief existence and our own ambitions to explore other planets, other civilizations should, with enough time and technological progress, have ventured into space for resources or communication. This idea, however, stands in stark contrast to reality. Despite our intuition that the universe should be bustling with life, we have found no evidence of extraterrestrial civilizations. This discrepancy is known as the Fermi Paradox, which underscores the striking gap between our expectations of a life-filled universe and the apparent emptiness we observe. This conundrum is often referred to as the Great Silence. The search for extraterrestrial life, despite our long-standing fascination, is a relatively new scientific endeavor. The most renowned organization dedicated to this quest is the Search for Extraterrestrial Intelligence, SETI, which began its official operations in the late 1950s. SETI focuses on sending radio signals into space and listening for possible signals from intelligent civilizations. While SETI's efforts are aimed at detecting intentional signals, it's important to remember that our technology has been inadvertently broadcasting radio waves into space since its invention. These include transmissions from mobile phones, televisions, FM/AM radios, and even the earliest radio broadcasts from the late 1800s. However, the enormous distances in space present a formidable challenge. Our radio signals may not have reached potential intelligent civilizations yet. Even the oldest transmissions, over 100 years old, have only traveled a tiny fraction of the vast expanse of space. To put this into perspective, if our earliest signals were to reach a hypothetical nearby civilization today and they immediately sent a reply, it would take another 100 years for their response to reach Earth. Without a breakthrough in physics allowing faster-than-light communication, we may never know if our efforts to reach out have been successful, and any potential contact might occur long after our lifetimes. If life exists not 100 light-years away, but within 50 or even 20 light-years, aliens would have had ample time to receive and respond to our signals. So why haven't they? One possible explanation is that aliens don't exist. However, let's consider the scenario where they do. To understand their lack of outreach, we can categorize alien civilizations into 3 levels of advancement: less advanced than us, equally advanced, or more advanced. If they are less advanced, they may lack the technology to communicate with us. Additionally, it's important to note that for 2 billion years after life began evolving on Earth, any civilization searching for signs of life here would not have observed the same indicators we're focusing on now. During this early period, Earth's atmosphere lacked significant oxygen, and life forms were primarily microbial. Similarly, an alien civilization might be at a stage where they haven't developed the means to detect or send signals across space. Another possibility is that alien civilizations are as advanced as we are. In this case, they might be hesitant to contact us due to uncertainty about what they might encounter. This aligns with the perspective of physicist Stephen Hawking, who cautioned against reaching out to alien life. He suggested that extraterrestrials could view us as a potential threat, seek our resources, bring diseases we cannot combat, or have colonial intentions. Given humanity's history of mistreating those who are different, it is rational to be wary and not assume that an extraterrestrial species would approach us with benevolence. The third possibility is that aliens possess vastly superior intelligence, making humans uninteresting to them. This challenges our human-centric perspective, but aligns with the notion that if the universe is teeming with life and there is nothing particularly unique about us, there might be little incentive for advanced civilizations to reach out or visit us. For a civilization capable of harnessing the power of stars, humans could be insignificant in the grand scheme of the universe. Such advanced beings might focus on grander pursuits, leaving our relatively primitive civilization unnoticed. In this scenario, colonial intentions or interactions with us might hold little significance for a civilization so advanced. We would be akin to ants, perhaps momentarily intriguing, but swiftly overshadowed in the expansive cosmic panorama. Just as most people pay little attention to the ants they encounter daily, a highly advanced civilization might similarly disregard us. The abundance of life in the universe, which could potentially spawn nearby alien civilizations, might paradoxically explain why we have yet to detect their presence. Taking a more skeptical view, aliens may favor ambushes over friendly greetings. The dark forest hypothesis proposes that the universe is teeming with cunning civilizations that shun contact and instead observe silently from the shadows. According to this theory, just because we haven't been contacted doesn't mean nobody is listening. They may have even visited us already. Another widely accepted concept is the Great Filter, a crucial stage in the evolution of civilizations that often leads to their demise. This obstacle could be triggered by various factors such as asteroid impacts, volcanic eruptions, incurable diseases, runaway artificial intelligence, or self-destructive tendencies. The notion is that most civilizations encountering the Great Filter falter and eventually perish. If this pattern holds true, it could elucidate the Great Silence. Our civilization might be one of the rare few to have surmounted this cosmic challenge, accounting for our existence while others have succumbed. This explanation holds weight only if we assume that we have already navigated past the Great Filter. However, what if the Great Filter lies ahead of us, looming in the years to come? Perhaps our current existence isn't evidence of overcoming the Great Filter, but rather a sign that we are yet to face it. Potential threats such as future asteroid impacts, nuclear devastation, catastrophic pandemics, or the emergence of uncontrollable artificial intelligence suggest that our ultimate trial may be on the horizon, and our continued survival remains uncertain.